Question 4. Gordon and Brian leave a hostel at the same time. Gordon walks in a bearing of 45 degrees, so that's from north, 45 degrees, at a speed of 4.4 kilometers per hour. Brian walks in a bearing of 100 degrees, again from north, at a speed of 4.8 kilometers per hour. If they both walk at steady speeds, how far apart will they be after 2 hours? Well, first of all, we can work out what this angle in here is. It's 100 subtract 45, 55 degrees. We're then going to make a little triangle, joining Gordon and Brian together. I'm going to label up the sides. If that's H for hostel, I'll call that side small h. If that's G for Gordon, we'll call that small g. B for Brian, we'll call that small b, like that. Now, what we're trying to do is to work out how far apart they'll be. So this is what we're trying to figure out. We need to know the distance that Gordon has walked and the distance that Brian has walked. Now, we know that distance equals speed times time. We need to do this for both of them. So the distance for Gordon, his speed is 4.4 kilometers per hour, and that's for 2 hours, equals 8.8. So that's 8.8 kilometers here. Same for Brian. So distance for Brian, again, speed times time, 4.8 times the 2 hours equals 9.6, and these are both in kilometers. So 9.6 kilometers. So now we've got a triangle where we've got 8.8, we've got 9.6, and we've got 55. So because we've got the angle on the two sides next to it, we can use that information to find out h using the cosine rule. And the cosine rule is in your formula sheet. So it's written as a squared equals b squared plus c squared minus 2bc cos a. However, we don't have a, b, and c here. We've got b, g, and h. So h is the one we're trying to figure out. So I always like to write down at first h squared, and so don't accidentally put the wrong letter in. If it's h, I'm needing here, it's cos h I'm going to put on the end. It's just my personal preference to do it that way. We've got b and g, the other two sides, doesn't really make any difference which way around you put these. That's multiply there. So we can substitute numbers in here, and then we can take the square root at the end to work out what h is. So we substitute in b, 8.8, g is 9.6, and it's going to be cos of 55. We work all that out. We get this. And that's for h squared, and we want h. So we've got to take the square root of that. I'll write it unrounded first, and then I'm going to round it just to one decimal place. It'll be fine because these are all just one decimal place there. So it's 8.52, etc. So it'll just be 8.5 kilometers, and that's to one decimal place. So 8.5 kilometers apart. Question number 5. So the diagram shows a mirror which has been designed for a new hotel. The shape consists of a sector of a circle and a kite AOCB. So our sector is this section here. Then the kite is the AOCB, so we've got a kite here. Given a variety of bits of information about the circle and the kite, we've got to find the perimeter of the mirror. So to do that, we need to find this measurement here. That's your major arc. And we need to know this length. And we need to know this length here. So we're given a variety of bits of information. So if I want to find out this length here, that's going to be the major arc. So I need this angle. Well, that's 140. So if I take that away from 360, I get 220 degrees. So that's my angle in here. I also know that I've got a radius here. That's a radius here. And a radius and a tangent tells us that a tangent here meet at 90 degrees. So we have that. So then we can split the kite into two triangles. And we can figure out what this length here is in just a minute. We'll work out this length here first though. We know there's a radius of 50 centimetres, so I'll put that into the diagram. So first of all, we're looking for an arc length. So the arc length formula is one you need to remember. So arc length, it's your angle at the centre. So sometimes you see x, sometimes it's called theta, doesn't really make any difference, over 360 times pi d. Pi r squared is if it's an area that you're looking for, but we're looking for a length of an arc this time. So if our radius is 50, the diameter is double that, so that is going to be 100 centimetres, and our angle is 220. So we can work that out quickly. So it's 191.9862, etc. So that'll just round to 192 centimetres. So that's this measurement around here. We can now focus on working out this measurement here. Because remember, we're looking for the curved section and then these two straight sections to get the total perimeter. So focusing on this triangle on the right here, we've got a 90-degree angle. That's 140, but it's being split in two, so this angle here is just going to be 70 degrees. We've got 50, and that's the side that we're after. So we could use our basic trigonometry, commonly referred to as SOHCAHTOA. You could also use the sine rule if you preferred. So there's my 70 degrees. This side here is the hypotenuse, because it's across from the right angle, so I'll just label that H. This side is the opposite, because it's across from the 70. This is the adjacent, because it is next to the angle. Okay, so we're trying to find the opposite. We know the adjacent, but we're not really bothered about the hypotenuse. So it's the opposite we want. We've got the adjacent. So it's going to be tan is opposite over adjacent. Well, x is 70, because that's the angle. So tan 70 is equal to opposite, and that's the one we don't know, over adjacent, which is 50. So multiply both sides by 50, and that'll give us the opposite. And that comes to 137.3738, etc., which rounds to 137.4 centimetres. So to get our total perimeter, we're going to add together that, and then that again, because we've got the two sides. So 192 plus 137.4 plus 137.4. Which gives us 466.8 centimetres perimeter.